if you want to ask our guest for something, I will give you a microphone because we have a video shooting in the corner, and it will be more convenient for our guest if you ask him in English. Okay? Okay, thank you.
Thank you. Good afternoon, and thank you for coming. And English will be actually probably the only language I can understand here today. My middle name is Panchiniak, Rodrigo Panchiniak Fernandes. This name, as you might guess, is a Ukrainian name. By chance, I'm very honored of coming here for the first time in Ukraine because it is the motherland of my ancestors from my side, the side of my mother in my family. So thank you very much for coming. I'm from Brazil actually, and it's my mother was from a very small city that has this picture. So, but I was born in that order. That is not too far from the second one. So I think it's more than 100 years ago, a group of Ukrainian people and Polish people, they went there, they founded this village. And by another side of my family, my father, ancestors came from Portugal. So this is why I have also Fernandes in my name. Okay, probably everyone is a bit tired already. Big event already, right? A lot of information coming around. And now I'm going to talk a bit about encryption. That may sound a bit scary. And when you go deep on the mathematics on how it works, if we don't read it, if we don't get by the start a friendly explanation about it, it sounds scary and difficult, but actually it is not, and it cannot be, because it needs to be simple to be safe. And what this presentation is about is a Drupal contributed module called Protected Content, short name PROC, P-R-O-C, that in this module is a wrapper around JavaScript library that does encryption on the client side, or in other words, in the browser. So this JavaScript library is Open PGP.js. So how it works, what we have now in Drupal, I can show you the Drupal.org page that contains information about the module. This is short name PROC. You could read, if you are brave enough to test it. It's still a development version, not yet with a tag. Soon I hope it will have, and also until now only Drupal 7 version. I hope soon I will have enough time to release a Drupal 8 version that is already in progress. So you have here a link for the OpenPGP.js library. This is a very powerful JavaScript library used in a service called protonmail.com. So how it works? It is going to make the encryption of your data before it goes to the server. So in which scenario this is desirable? When someone should want to have such a powerful and strong security. In the case that is not so uncommon nowadays, of a massive leakage of your server. For example, in the worst case scenario, someone took over the server, or the system administration got crazy, got mad, and he decided to leak all your sensitive information, all your users' data in the server. If this last barrier against attackers fails down, everything is lost. So, which is the solution we could see for avoiding this, even in the worst case scenario, is that not even the system administrator would have access to the data that is intended from user A to user B, or from user A to a group of users. This is also possible. So what happens, encryption happens in the client. When you submit the information, it's already encrypted. It goes to the server, stored in the server, already encrypted, and it will be decrypted again in the browser. So no one will be able to access it unless the person has control over the machine that has sent the information. It's also interesting that this happens with password. You need the encryption password, and encryption password is not stored in the server as well. So you cannot decrypt the information if you don't have the password. And password, if the user is sensitive to this need, the password will be stored only in the mind, in the brain of the user that has created it. So there is no way to recover the password, at least not known. There is no mathematical way to recover the password from the keys. And when I'm not a specialist in encryption, I'm working with Drupal for the last 10 years already, so I'm kind of specialist in Drupal. And I needed to learn a lot of concepts of encryption to be aware, to be sure of what I was doing. And what this system uses is a system of public and private key. And there is this may sound a bit difficult to understand, but at the end it's not that difficult. I'm going now to show you a bit, let's do an overview of these slides, and then I will come back over then slowly to show a bit more of each slide. And also, hopefully, and I think today we are lucky, I will do a demonstration of the model for you, okay? Probably to fail, let's see. This is about the key generation. PGP, pretty good privacy, and more especially Open PGP that became a standard. It uses some terminology to describe some concepts. Key ring is the Open PGP terminology to describe these pairs of keys. So you have a public key, encrypted key. In this system, Open PGP.js and this Drupal module that is going to use the API of this library, what it does, it generates the public key, and it generates the private key. But the private key is encrypted before being sent to the server, okay? So the public key can be accessed, needs to be accessed all around, so it's okay. And the private key is encrypted, right? The model provides an address that has changed in the latest days, but it is a PROC. This is the name of the short name of the model, key ring add. And this is how a user will choose a password to generate the key. Once the key is generated, the user is able to receive files. A user does not need to have keys to send files, but the user needs to have generated keys to receive files, okay? So for sending to someone, the user will be able to send to himself or to other person or to several users in the edition that have registered keys. There is also a hook menu. So in other words, a route to send encrypted file. We have the last parameter, it's a constant value list of user IDs. As long as these users have registered keys, I will be able to encrypt file for them. File was the most difficult part, but this can be not very difficult to make this available also for fields. But here the idea is to treat files at this moment. So after the user chooses a file, the files will be encrypted by the public keys of the users choosing to receive the file. Okay. And once that happens, if the encryption goes well, the save button becomes available, and the user is going to submit what? Not the file. It will submit a ciphertext, that is the encrypted representation of that file. Only that is what goes to the server. So the file never leaves the browser, and when a person is going to receive that file, actually the person is going to receive the ciphertext. The ciphertext is going to be converted back to the file. So if when the encryption goes well, the sender, the user that is going to send that information, gets a link to be shared with the person that is going to receive. How this sharing part is going to happen? This, until now, the idea was to make the model generic, so every implementation, every Drupal project that's going to use this model can handle this in a different way via hooks. So, for example, once this happens, I can send a notification for the user that's going to receive, for example, or any other kind of way to share this link with the user that's going to receive the file. So this is a process of a series of transformations that happen with this information. We can see a bit more in detail later. And once I'm the person that's going to receive that file. There is an address, the previous one. This is the ID of the entity that is going to give me access to that ciphertext. Until now, I only have the ciphertext, and the system has my own encrypted private key. Now, this password is going to decrypt my private key, and with my private key, OpenPGP.js in the client is going to decrypt the ciphertext, and then the file will be available in this link. It's interesting because the file, again, has never left the browser of the person that sent it, and is going to be generated on the fly in the browser of the person that is going to receive it. So if the password that has been typed in was wrong, there is an error message that comes exclusively from OpenPGP.js. So everything in JavaScript, nothing of this check comes from the server. So here I have a bit more of details of this process, and let's now move forward a demonstration, a live demonstration. And after that, if we still have time, there is an explanation, a metaphor of what is public key and private key encryption. It's an interesting metaphor created by Simon Sain, an author based on United Kingdom. He's a journalist and writes about mathematics. He writes very nice books. For example, the Code Book and the Last Theorem of Fermat. I just leave it as a suggestion of reading about encryption. Now, if we are lucky enough, I'm going to demonstrate for you how all of this works with a kind of fresh install of Drupal here. I'm going to make it a bit bigger. So let's imagine that this user does not have registered keys. It has registered already, but this is why I have a message here saying that you have registered protected content keys, and you don't need to register new ones unless you have lost your protected content password. And this is interesting. This password cannot be recovered. This is let's say, a bad side effect of the process. Actually, it's the guarantee of the security. So the password cannot be recovered. And if the user loses his old password and creates another keys, another pair of keys, he will lose access to everything that has been sent to him previously. So the people, the users that have sent to him something, they would need to send it again. This is a constraint in this approach. Okay, so let's create here. I'm going to type 1, 2, 3, and 1, 2, 3 again. This is not enforcing any minimal length, so it's up to the builder or the project owner to decide if they want to enforce a minimal length. Now, let me show you how this key look like. I'm going to show in the database. We have a field called armored. Armored is the format. It's a ASCII representation of the key, and we have here two bundles in this field. So it is being used on key ring and also for the ciphertext. The latest one that we just created is this one, and then let me open it. Can I do that? Not I. So let me make it a bit bigger. So this is a public key, and this is an encrypted private key. Now, this user is already able to send it to himself encrypted file or to send to other people that has registered encryption keys as well. For sending, I'm going to another address where I needed to type the user ID of the recipient. I could have, this is already integrated with views. I could have a list of users and a link for each of one of them, or I could have a batch operation that would make me able to select several users and with a single button to have the address that is proc at and 1. If I would have a second user, I would just put a comma in the user ID of that user. So let me send to myself, and now let me choose any file. Now we have a new ciphertext that I can access with the password that has been typed on the creation of the pair of keys. 1, 2, 3 in this case. And the file is there. And that's it. For the metaphor I was talking about, that a bit explains what means encrypting by public and private key is the following. And this is, unhappily, I don't have the lockers I would like to have. It's the second time I don't have these lockers with me. But okay, you need to imagine. Imagine I want to send to someone a letter, and I have a box. I put my letter inside this box. In this box, I can put a locker on the letter. Or I put a locker on the box. And then I send to someone this box. The person doesn't have the key. I keep with myself the key of the locker. The person receives the box with a letter inside and one locker on it. Instead of trying to open the box, the person puts another lock, a locker that the person himself or herself has the key. And now the box is with the person that's going to receive the letter, but instead of opening the box, the person has a box with two lockers. And the person sends me back the box. Now I got the box with two lockers in it. One of the lockers is my own locker, and I have a key for it. Then I open the locker, And now the box is with me. I'm the sender, but I'm again with the box with only one locker that does not belong to me. This locker belongs to the person that has sent it back to me. Now I send again to the person, and now the person has a box with only one locker, but this person is the owner of the key for that locker. So this kind of represents public and private key encryption. It's not really mathematically correct, because I can send an encrypted message with a public key of someone, and I don't need to have keys myself. Okay. Also, we have here an explanation on 10 steps of this the mathematical process that happens on the RSA algorithm. That is the algorithm used by OpenPGP for the public and for the use of public and private key. Also, a bit more of details on which algorithms are in use. So we have symmetric encryption of the private key, and we have asymmetric encryption and decryption of the content itself. The symmetric encryption is, let me go back to my documents. AES 256 is the algorithm that does the encryption of the private key. This is a symmetric algorithm. This is why we don't get into a chain of using, I have two keys to encrypt and decrypt my data, but I don't need two keys again to encrypt and decrypt the private key. If it were like that, I would get into an infinite chain. It's not like that. So, encryption and decryption the private key is a symmetric method, and encryption and decryption of the data itself is asymmetric, meaning using two keys. Asymmetric is always used when you have one way to decrypt and a different way to decrypt. When you have a symmetric encryption, it's actually same function going from one side to the other. This algorithm that does the asymmetric encryption, it depends on a mathematical phenomena that is a function, a mathematical function that is easy to go from one side to the other, but it's very hard to come back. This is based on prime numbers. And there is a very nice explanation on the code book on very simple 10 steps. We could go through them, but I don't know if we are in the mood of doing this. Let me just go very fast over them. So you have here two prime numbers, 17 and 11. You do a series of mathematical operation. It's really simple. It may look like difficult, but it's not. And if you go over these steps at the end, you can do by hand the encryption of one letter. For example, this is the encryption of letter X. So it's really nice to understand better how this works before you get serious in a project of encryption. And it's not difficult. So I'm not going through this now, but I leave it as a suggestion of reading for you. Okay. I don't know if we have questions.
What about performance and synchronization?
Yeah, this we were very worried when we started doing this, because how the browser would behave on this. And luckily, OpenPGS is very performant. It uses modern JavaScript, and we were able to encrypt files up to 60 megabytes, 60 megabytes, almost immediately. It's really very fast. For some browsers, it's not like that. We had some troubles on some versions of Firefox for the generation of the keys. But in the latest versions that have been released of Firefox, that is not happening anymore. So the experience I have, I don't have it's still not in production on the client that has requested it. So we still don't have much information to give a precise picture of the performance. But the model is storing some meta information about that. So I'm storing, together with the ciphertext, I'm storing the file name, the size, and how long it took for the browser to link that file. The same thing we are doing for the keys. So if I use or in some case we need to debug something that's not going well, we would be able to recover this kind of performance information.
One other question.
I'm sorry, in the microphone. Oh, sorry.
Probably the most security rate to store private key password protected on clear file, not in the cache.
Yeah, but this is what we do.
Like an option. So we can store on the cache, two keys, one of them protect, one of them protect. Or another option, store only on clear file. And in this way, we have any idea to decrypt this information.
Yeah, you mean we could.
Like a variable.
We could use the DOM to store that information while the user has the session open.
Store local storage.
Yeah.
Like
Yeah. This way, user would not need to type again and the password to have it. Yeah. This is also something that we are thinking about to have.
Yeah, because battery is low. I'm sorry.
I can speak loud.
Yeah, okay.
So basically my question is, how do you get your library into launch model? How do you get it?
Yeah. Until now, it's up to the developer that is going to install the module to download the library and to install it. We don't have a make file for doing that automatically. Yeah. Yeah, we are thinking about that, to have that. And then only Drush DL, Drush enable would do everything, yeah.
is it possible with module to protect most or call it?
Not yet, but this is one idea. And actually, it's more simple to do with text that will be available more easily than to do with a file. Because the file, there is a process. Let me go back to it to in a bit in detail which is the workflow, the cycle of transformations that happen to have this work. So here, ciphertext ASCII armored format is ready to be submitted. So file was ready in the client as file reader object and converted to uint8 array. So this is a representation of a binary file, but with numbers. That a readable string is started with it and composed together with recipient's public keys. The options needed at OpenPGP encrypt. This is the method that comes from OpenPGP.js library. So you have OpenPGP.encrypt, and here options. Options, you need to have the public key of the person that is going to receive and the uint8 array information that came originally from the file. So here, everything is treated as binary. If you have a text file, it is going to be treated as binary. If it is binary, again, obviously binary. But actually, this was more difficult than to deal. I could deal with text that it would be even more easy to do. There is one interesting situation that we could think about. For example, I have just a Boolean field. Even a Boolean field could be encrypted. the ciphertext would be way bigger than a bullet field, but it could work. See?
Any questions? Okay, so let me thank our guest and give our team a special.
Thank you.